update overnight. So what you see in Canvas should now look like what you see in um, Infinite Campus. Let me get a quick check. All right, there are still some comparative analysis assignments that I have not checked, but I am getting there. They will be checked by the end of the day. So there's about 4 of you who haven't done that. So again, everything is due by the end of today, so that grades will be posted tomorrow. All right, and I'm very happy to say that I only have 2 people who need to step up their game. Otherwise, I'm very proud of y'all. Y'all are doing very well. Very, very good. Very, very good. Okay. All right, let me just give a quick check to think everybody who's going to be here is here. All right, so while we're waiting, somebody tell me what the first S of CIS should be. You can type it in the chat. Sweetie. Okay. Where's it go? All right. Thank you, Kayla. Okay. All right. Everybody says secure the scene. Good job. Um, second S. What is the second S? All right. Separate the witnesses. Good job. All right. Give me 1 second after. Okie dokie. All right. Third. Scan the scene. All right. And again, notice all of these start with an S. That's why they're called the 7 S's. Fourth. Okay, see the scene, see the scene. With photography, thank you, Alyssa. That it's important to know how we're seeing the scene. Yes, indeed. Take pictures. All right, 5. Sketch it. Okay, not only do you want to photograph, but you want to sketch it. Draw out important things that you see. 6, search for evidence. Okay. And 7, secure the evidence. That was important. All right, so the activity that y'all did with, let me let these folks in, sorry. Um, it was important to secure evidence with the Casey Anthony case. The evidence didn't really, even though they knew she did it, because of the way they found the evidence and the way the condition of the evidence, they weren't exactly able to say she did it. So she got away with that. They sent her to jail for some other things, but she didn't go to jail for murdering her daughter, which everybody still to this day believes she has done. All right, let me quickly get these folks who are absent. So we're going to just look at human remains section today, and I have a short video to share with you. Uh, okay. All right. Just give me 1 second to get that loaded. All right, how I'm doing this. All right, I'm fixing test grades today. I thought I'd fixed yours, but I'm going to check on that in just a few minutes. Was there anybody else who's here? I'm looking, I think the people that I needed to see for the test are not here. All right, give me 1 second to get this code for somebody. And then I will share the video. Copy. All right, while you're watching this video, jot a few notes about um, what she says or what the specialist says. It's not very long, so you got to listen quick.
There are 40,000 unidentified sets of human remains right now in this country, and it's only possible to identify someone if there is someone looking for them. It's a slow process from discovery to identity. An Arizona State University forensic anthropologist breaks it down into 3 stages. First, recovery after the discovery.
A forensic anthropologist would be called. There are more skeletal elements to deal with the younger the person is. The ends of the bones aren't fused together. For example, one bone may actually be 3. So it could vary anywhere from over 500 to about the adult, 206. It's more labor intensive. You have to be very detailed in your analysis.
Second, examination and documentation in a lab.
Lay out the body as a skeleton. And so, it's a process of identifying what bones are what. And then they would, photo document, take handwritten notes, and then they would begin sort of their assessment. And that assessment would be, in a younger adult, be primarily measuring. So they'd measure all the long bones, estimate age, as well as stature, look at the dentition, any of the teeth that are there. They would probably want to use, some fairly low resolution microscope, and just look at the surface of the bone to see any areas of possible trauma.
Finally, additional testing such as DNA.
The sex of the individual. So they will look for presence of the Y chromosome. They would want to develop the profile, the biological profile, the molecular profile of this person. And depending on the lab, it'll probably be 13 characteristics that they're going to try and determine what they are.
Scientists can try and match that up through a DNA database. Parents of missing children usually have their DNA in that database for that reason, which comes back to you can only be identified if someone is looking for you. Again, this is a slow process. Many cases take weeks, even months to complete. But we're told children typically have a higher chance of being identified because parents usually want to find their kids. Crystal Henderson, 12 News. There are 40,000.
Alrighty. So, what did they say? I think Kenzie's having trouble joining. All right. So what's the first thing I'm gonna stop sharing for a minute because the first thing you're gonna see is the grade book, and I don't want that to happen. What's the biggest problem in identifying remains? Okay, thank you, Kayla. You can only be found if somebody's looking for you. If nobody's, and then you'd be surprised how people who are alone, like they said, adults who are alone and go missing, and nobody notices that they're missing. And so, and the police are not just out randomly looking for the remains of bodies. So if you're, I'm sorry, I'm looking at this person is trying to get in, but they're not getting in for some reason. Okay, there they go. All right, so what's the first thing? So after you find the remains, so somebody starts looking for you. What's the first thing that so let me back that up. Which type of scientist is going to be studying the remains? What's the name of the scientist they said we're going to turn this over to? Anthropologist, a forensic anthropologist. That's what my daughter went to college for, and she got sidetracked. She just graduated as an anthropologist. Yes, Kenzie, you're not the only one. I can see the trouble you were having. All right. But yes, someone who not only just studies bones, but they are studying bones to detect why they died. Okay, so you have some anthropologists that are just trying to collect and they're studying history and wanting to know culture, but the forensic anthropologist is interested in figuring out why this person died. Why are we looking at the remains of this individual? All right. What's the first thing he did? Hopefully y'all jotted down these notes. And if you didn't jot them down, you're jotting them down now. So first, somebody has to want to find them. Secondly, your forensic anthropologist is going to do what? What's the first thing he's going to do? Okay, they're going to recover them after they in other words, you're going to find these bones in a plot or located somewhere because by the time they find bones, they're usually buried somewhere. So you have to recover them, meaning collect them all, collect them carefully, and take them back to the lab. All right, what's the second step they're going to do? Hopefully not only Kayla was paying attention, somebody else paying attention. Thank you, Kayla. All right, thank you, Bria. And they're going to measure them, estimate the age and teeth, ex and exactly, examination and documentation. Exact. So in examining, they're measuring and they're and then like they said, they said children were easier to identify because for school purposes, you have to go to the dentist, you have to go to the doctor. So there's a lot of documentation about children on file, as not so much like adults may not do anything after they leave school. So that kind of gets lost along the way and they move. And so it's easier to find documentation for children because they have to go to school. All right, and what's the last thing we want to do? Third thing? Anybody? Anybody? All right, check the DNA base. He mentioned X chromosome. I'm sorry, he mentioned the Y chromosome. What's the Y chromosome? What's the significance of a Y chromosome? See if you remember your biology. Anybody know remember the significance of the Y chromosome? Or what are chromosomes? When you study DNA, they're studying your chromosomes. Um, all right, Curtis, thank you. Nice that a guy knows what a Y chromosome is. Only men have Y chromosomes. All right, both men and women have an X chromosome, but only men have a Y chromosome. So studying the DNA will identify that chromosome, and then they can decide whether this person is a male or a female. So they can start with that. And then once they identify the sex, then they can look for other features that are typical of a male or a female. So identifying the DNA can give them a lot of information. It can give them blood type and other information that might uh, basically help them if other things are not on file. Okay. Um, let me, right, if you have not, give you a few minutes while I do tidy up the attendance. If you have not done the slideshow for how old are the remains, please do that and then I'll share as soon as I finish attendance. All right, so I'm looking at GoGuardian. Everybody should be looking at forensics, looking at the slide show on bones. Everybody. Already I got a couple of people idle. When I look at Go Guardian, I shouldn't be looking at me. I should be looking at you doing what you're supposed to be doing. And I got 3 people who are looking at me. Canvas, folks, Canvas. Caitlin, you logged in, but you're not doing anything. Abigail, are you with us? Okay, while I'm here, let me do a quick check of the grades. Like I said, I'm still, so if you finish the test, all test scores are in. Um, okay. All right. All test scores have been updated. And like I said, there's a couple of people who I still haven't finished looking at your comparative analysis, but from what I can see at the moment, um, the grades and how they average things is slightly different. But it's gonna you want to look at you want to round it up to the nearest. So don't look at the decimal so much because it's going to round up as a whole number um, at the end of the day. So the posted grade and they're still kind of off, but for the most part. All right, Xavier, I see what you're saying. Your Canvas grade and your, huh. All right, so I'm still going to do some checking on some of these, but I promise you I will check before I post to make sure that the two columns match. I think sometimes it's posted before it's been updated. So let me do this. See what happens. Okay, that fixed it. All right, so yeah, it just needed to repost. So Xavier, you're good. Real good. All right. So yeah, it's just going to post and it'll post again. Like I said, some of you I haven't finished reading your case studies yet, so I do have to post again. But right now, um, it should be the way it should be. Okay. All right. That being said, all right, because they said we could post several times. The final post will happen Friday at 3 o'clock. And so whatever is posted at 3 o'clock on Friday, that's the final grade. Okay. So just make sure anything you need. And like I said, most of you have done a really good job of doing anything that's outstanding extra. So the only thing outstanding is on me right now. And so that's great. That's great. That's great. Okay, okay. Having done all that clerical stuff, let's look at all right. And we're off on Monday. So I don't see you again until Wednesday. Just just a reminder, you're off on Monday. Regular classes tomorrow, off on Monday. All right. Okay. All right. So in addition, if you've ever looked at anatomy, some bones in some organisms, what they call, are similar, and some of them are not. So you can look at bones and decide whether it's a set of bones belong to an animal or a human. So that's one of the things that you need to determine. All right, so how good did you go through and identify these? How'd you do? Because most skeletons intact, and then a lot of times you don't find the skeleton intact. You've got to collect it all and put it back together. If they were left out, and then I know this early in the morning to be so gory, but if they died out in a field somewhere and animals started to tear at them, the bones might not all be in one spot, so you have to put them together. So these probably are collections, the ones at the top are collections of things that they've put together. They didn't find it, might not have found it all together like that. All right, so a sloth is usually pretty easy to identify because they have those long limbs for hanging in trees. Giraffe would be easy to recognize because of the long neck. So, and this snake would have been easy to recognize because of the structure of the skeleton. Finding skulls is different. So knowing the shape of the skull can tell you the difference between one organism and the next. And then this one, you would Again, you can tell the difference between this one and the chimpanzee, and just know that it's just been deformed, but it's still a human skull as opposed to being a chimpanzee skull. All right, hopefully you all went through all of these and looked. I think we talked about this one before. All right, you see these in movies, centaurs, but not necessarily. All right, so hopefully you went through all of those. Okay, when you're looking at bone structures, porous is a word that you need to be familiar with. It means that the bone is not solid, hard like we always want to think of it. Bone is referred to as being porous, as got like a sponge. What's the name on this slideshow? We are in Canvas and we're in human remains. And yes, you can go to the restroom. Hurry up back. Alrighty. So you need to know that if you were looking under a microscope, and you were looking at bones, this is what a normal bone uh, picture should look like. Okay. And then they're telling you, so you need to know that humans are more porous. So they have more, like the picture off to the right, have more spaces in between. And non-human are less porous, the thickness and diameter. They're looking at thickness and diameter of the long bone. Okay. All right. You need to be familiar with the word osteo. So you've seen commercials and they talk about osteoporosis. As you get older, you lose bone structure and bone integrity. So the osteocytes are your bone cells, and they deteriorate as you get older and become more porous, and therefore they're more likely to break as you get older. So you have osteo. So we know that term osteo in terms of bones. All right. When they're looking here, um, human bone cells are scattered and evenly spaced, whereas non-human bones are aligned in rows and rectangular patterns. And I think they had a picture. Actually, they had a picture on the video that we just looked at. All right. And again, hopefully you've. So a lot of times when they find remains, they find open graves where if these people dies in masses, and so they just buried everybody in one. There's a lot of that going on right now in the Middle East where so many people are dying all together, so they have open graves. So then you have to sort out the bodies. Alrighty. All right, so one of the things they're going to, is we're not looking at skeletons, so and the skin is still intact. We can look at the coloration. So let's jot down the note coloration, skin coloration, and look at what you're supposed to be seeing. You know what your skin looks like, and you need to know things like are there bacteria growing on it? Does it have sun damage? The skin can also tell you if there's organ damage. Certain spots that people call liver spots show up on your skin, and they can tell you about um, liver disease. The color of your skin to tell you how much blood loss. The elasticity of your skin can tell you about water loss. So there's a lot that you can learn by just studying the skin of the person that you're examining. Um, Insulation is the amount of fat tissue. The temperature is also regulated by your skin. Your skin is again that outer protective layer that keeps you safe and warm. All right. Responding to stimulus is something that the skin also does. So its ability to respond when you how long it's been how the person's been dead will also be can be determined by the responses on the skin. And it's the place where you get your vitamin D. And again, I'm melanin. You need to know that the pigment in your skin is melanin and is responsible for skin color. Okay, so you make sure you make a note of that. Vocabulary, vocabulary, vocabulary. Okay, the melanin protects us from the ultraviolet lights from the sun and protects you, helps prevent skin cancer. Okay, so the sample of the offender's blood left at a crime scene might one day reliably yield important information that could significantly impact for the suspect. In other words, they can tell your blood from the suspect's blood, and hopefully that will give them some outliners as far as evidence, who it is and who it isn't. All right. These are all vocabulary words. So next time I see you, like I said, it will be Wednesday. So we'll do a little quiz on Wednesday of what these words mean. All right. So I don't want to go through and read out loud. So hopefully you all have read these. So I can give you about 5 minutes to click through and read those. But make sure you click everything that needs to be clicked. I have a little matching activity. All right, so you see with this one, just knowing the purple spots tells you that they might have been poisoned, they might have been electrocuted, they might have an infection. So the coloration tells you something. And this is what, in addition to for this class, in addition to knowing what the word means, you have to know what does that have to do with forensics? You know, what evidence is that giving you? Oops, sorry. Didn't mean to do that. All right, this is an important point too. Again, not just knowing what the coloration means, but knowing that, excuse me, the immune system doesn't function properly. What is the importance of the immune system? Why is it good to know that when a person dies, their immune system, all their systems stop working really, but in particular, the immune system no longer functions. And the immune system protects you. So if it's not working anymore, then the bacteria that used to be fended off by your immune system are gonna have a field day now because there's nothing to stop them from feeding on your skin. All right. Appears marbled and dark after death. So marbling. Um, Most of you, some of you might have marble kitchen counters. So this one they say marbling. This you have an uneven coloration where it's dark here, light there. It has a marbled appearance to it. Okay. All right. So again, know not just what each of these words mean or what each of these identification signs are, but know how that's connected to forensics. So definition and forensic identification. All right, take a few moments to read through this. It's a lot to read. And we'll stop there. All right, so everybody needs to read this page. Make sure you've read it. Go through all three of these cards. And take note of this. All right. So I'll give you a chance to read through that and jot down some notes as you read. And end up here. Make sure you particularly jot down these facts here. All right, I'm going to stop sharing. I'm going to check GoGuardian to make sure I'm doing this. Check on my other friend. Aladanian, remember this last chance. All right. Hopefully you've had a chance to read that over. I'll share another video with you. This one looks like they're ready for Halloween. All right, let me get Uh-oh.
Pennsylvania. It isn't plastic, an old skeleton hanging in the art room of this high school in Erie, Pennsylvania. It isn't plastic, it's made of real bones that belonged to a real person, but no one knows who that person was. Not the art teacher, Mrs. Leisure.
I have no idea where he came from. It could have been here for 100 years.
Not the principal, Mr. Vieira.
The lore is it came from the Ganges. We consistently hear that it's male based on the bone structure.
And not my friend Alyssa Nadwarny. She went to school here, and now she works with me at NPR.
When I found out my school had a human skeleton, I wanted to find out everything I could about it.
So here at Skunk Bear, we decided to see what science could tell us about these bones.
On TV, they always start with one thing.
Her DNA. DNA?
DNA sample?
DNA.
So we took the skeleton to a DNA expert at the Smithsonian's National Museum of Natural History, Dr. Logan Kistler, and asked, can you get DNA from an old skeleton?
It's probably going to take 4 to 6 weeks of lab work and analysis, probably cost up to about $5,000.
Okay, so no DNA analysis. We needed to find someone who could tell us something by just looking at the bones. So we went back to Erie, to Mercyhurst University, where we met Dennis Dirkmaat. He reads bones for a living, working with law enforcement to identify remains associated with crimes.
There's a lot of information to be told from the skeleton.
He called in some colleagues to measure every inch of our skeleton. First up, is this skeleton a man, like everyone thinks?
We usually start with the pelvis.
Females have broader pelvises to make childbirth easier, but this pelvis is kind of hard to interpret. It's somewhere in the middle. But there are more clues in other parts of the body.
A very clear marker is the mastoid process.
That's the bony bump where the jaw muscles attach to the skull. Men have bigger jaw muscles, so they have bigger bumps than women, and this skeleton has a small bump. And there are other clues too. The shape of the eye sockets, the brow ridges, the curve at the back of the skull.
All the features here indicate that this is female.
When we walked in here, we thought for sure this is a male.
Okay, next, was she young or old? To get an age, Dirkmaat's team looked at places where the skeleton's bones had fused. See, we're born with about 300 separate bones, but around the time we hit 40, we only have 206. That's because at specific times in our lives, certain bones fuse together. 2 plates at the front of the skull fuse in our first year. Our upper arm bone fuses in our teens. And then there's the clavicle.
There's a little line there that tells us that it's in the process of fusing. This is probably somebody 20 to 30, probably mid-20s.
Wow, I wasn't expecting it to be that young.
Next, her height. Dirkmaat's team took a few bone measurements and used them to calculate how tall she was.
This one came out just a little above 5 feet.
How tall are you?
5'1" or 2.
I'm 5'3".
This is sort of like almost you,
I know, it's
in
really
a way.
freaking me out.
The other aspect of the big 4 in our biological profile is the ancestry.
Dirkmaat's team compared her head measurements to a digitized database of skulls from around the world. And another surprise, the computer program says this skull looks most like a Japanese female. But there's a lot of uncertainty here, and the most Dirkmaat will say is,
It's probably Asian.
So we're starting to build a life story. This is a young woman who has Asian ancestry. So the next question is, where is she from? Did she grow up near Erie, where we found her? Or could she have lived in Japan? Or near the Ganges, like the principal heard? Well, I did some research, and it turns out that a lot of skeletons in medical schools, art schools, and high schools actually came from India. There was a shady but legal trade in human remains between India and the West that started in the 1800s.
So can we tell if this skeleton got here as part of that bone trade? These bones probably hold more clues. They're just hidden deep down in their very atoms. So we sent off a very tiny piece of bone to a geochemistry lab to see what they could tell us.
Hello, this is Doug Kennett calling from Penn State.
Hello!
Hey, Doug.
Kennett is the guy who got our sample, dunked it in acid, burned it into a gas, and sorted its molecules in this giant machine.
Believe it or not, that gave us a clue about where she came from by telling us what she ate.
This is sort of an old adage that you are what you eat.
If you live where they eat a lot of stuff made from corn, like in Pennsylvania, your bones have one chemical signature. No corn, but a certain mix of land plants and animals, like you'd find in continental Asia, a different signature. And if you eat a lot of seafood, like you probably would in Japan, different again. So, what did the bones tell us? This woman's diet looked like this.
Probably not an island or a coastal environment. So certainly consistent with someone living in India, Pakistan, sort of Central Eurasia.
So she could have come from the Ganges region, and she could have been transported to the US via this bone trade, but only if the dates line up. Did she die when this bone trade was happening? Kennett's first step was to look for a chemical timestamp. Back in the 1950s, nuclear testing flooded the world with huge amounts of radioactive carbon.
We call it a bomb spike in the atmosphere.
And anyone who lived through it or was born after it has lots of that radiocarbon in their bones. But in our sample, Kennett didn't find this marker.
So we can say definitively that this person did not live after 1955.
But he was able to read more subtle markers to figure out when she did live.
The most likely interval that this individual lived was between 1875 and 1920.
So it kind of fits right in that timeline that these skeletons would be coming to the US. And it's so weird to think that, like, at the beginning of this process, it was basically a pile of bones on a string, and then the more you learn about it, it becomes this real person.
All this new information just underlines a bunch of really tricky questions. Should skeletons like these be used in classrooms at all? And if not, how should we lay them to rest? No lab test can tell us what any of these people believed in, or what they would have wanted.
Okay. All right. So you see, there's a lot of. Let's start this before it goes on. How long is this? We got 6 minutes. We could watch this one.
There are 206 bones in the human skeleton, and in death, a person's bones speak volumes about their life.
We have to look at every single bone individually. And if we see an anomaly, we will look at it under the microscope. So the maximum length is 444 millimeters.
Authorities know very little about this man, including who he was, or even how he came to be in Wake County.
Every case is different, so it's always provides a unique perspective that you have to gain from looking at the remains. And there's always something different about them.
95 millimeters.
Authorities also don't know who killed him, only that he died violently.
It looks like we have 3 entrance gunshot wounds here. And this looks like a keyhole, so the direction would have been from superior to inferior, with the bullet trajectory going this way.
But forensic anthropology could be called the science of talking bones. So, law enforcement authorities from communities across North Carolina turned to the Forensic Anthropology Lab at North Carolina State University for help. They want to understand what the remains of crime victims are saying.
They can tell you a lot about the person, about how they lived, about everything that we do during our life actually leaves a mark on our bone. So, for example, we can tell if somebody had large muscle attachment sites, so you know they were physically active and were robust or rugose, meaning heavily muscle marked.
126.
The scientists give a voice to unidentified remains in more than a dozen cold cases every year.
They can talk about the diseases a person may have had in life. I can talk about, like in sort of spina bifida, what kind of prenatal environment they may have had, what kind of childhood they may have had, you know, if it affected their stature, if it affected their dentition, their diet, their sometimes even their climate, their whatever they're acclimatized in terms of altitude. All of these things can be readily seen and interpreted sometimes.
To find out where this victim was from, as well as the sex, Ross took almost 36 measurements of the skull. The information was entered into a database called 3D-ID. Dr. Ross helped develop it. The program compares the features of the cranium with those taken from people around the world.
We were able to establish that he was a Hispanic male. One of the things that we looked at was the shape of the face, the shape of the nose. We digitized him and took measurements off of his skull. His measurements allocated or classified into South American.
The pelvic bones also indicated the victim was a male. The femur can tell a person's height, in this case about 5 feet 5 inches tall. That correlates with the population of Chile. Missing teeth indicate poor nutrition. An examination of the chemical composition of the bones reflects the drinking water where the man lived. And since none of the chemical signatures in the bones are found in the water in North Carolina or anywhere else in the United States, it is likely the man moved to the state less than 5 years before he died. DNA is also extracted from the bones when possible to add to the profile.
One of the things that we look at, he has a slight spina bifida occulta, which you can assess that he had probably poor natal health during life.
Didn't fully
fuse. And that is a lot of populations that don't use folic acid, right? And we include that in all of our foods now. We have them in cereals and pasta, prenatal vitamins. So a lot of these populations, you would get those kinds of anomalies.
The focus is as serious as murder, but the remains are never treated as just a case number.
It's important to stay grounded and remember that they were a person like you and me. You know, what's to make that situation different? So you have to keep that level of respect, I think.
Because these bones belong to an individual, and I think about how I would want my remains treated if it was in my, you know, if I was on that table instead. And I would hope that it would be in the same way that I would treat another individual's remains.
It is challenging work. Some people might even call it gruesome. There are instruments in the lab to deal with human remains that aren't fully skeletonized. But just as every person is unique, each case is unique as well.
They're all very different, and you have to have very fresh eyes whenever you start a new case, because you're looking for something that a lot of times that you haven't seen on another skeleton before, or that you at least haven't come across very frequently. And you have to be cautious, but you also have to be open.
The goal is to use science to bring resolution to someone who has no voice. The information gathered from the bones will be passed on to authorities in hopes it will help identify the victim and solve a murder.
You wonder what made you get to the point that you could actually do such a horrific thing to a person. The worst cases for me are the cases that involve children. So people doing horrible things to children, you know, because they didn't necessarily put themselves in a situation that they found themselves to be in. Whereas a grown-up sometimes, hey, we make some bad choices. But with a child, they didn't have a choice. And I lose sleep over those cases.
Okay. Think about this over the weekend. When I see you next, I'm going to have you do a short essay on if my bones could talk. So write that down. And like how they were saying, if someone found your remains, what would your bones tell them about you? So think about the things that they just said in this video. What could they tell by looking at your bones? Okay, so think about that. That's going to be your next essay activity to do. If my bones could talk, what would it tell a forensic scientist? All right, folks, you all have a great weekend. Stay safe.
There's an old skeleton hanging in the art room of this high school in